All right, let's go over this Chapter 2 test that we just took and talk about how we did here. First of all, what type of discontinuity happens at -1, 2.5, 3.5, and 5? At x equaled -1, one side goes off to infinity and the other one stays here, but that's infinite discontinuity. It's an infinite difference. One or both sides heading off to infinity is an infinite discontinuity. And then at 2.5, the next place we'll look at 2.5, this goes from one height to a different height, just jumps down there, so that's called a jump discontinuity. At 3.5, there's a hole, and if this point was moved up there, that hole, that blank space would be removed, and so this is removable. And then finally, at 5, which is right here, it's continuous. There's no hole, there's no jump, there's nothing, so it's just continuous. Okay, now at each one of these places, we're supposed to give the left and right hand limits. Well, when it goes off to infinity at -1, there's no limit from the left side. It heads to plus infinity. So if you put plus infinity or no limit, I would have given you credit for it. And at that same place at -1, this side approaches a height of not 2, not 1, but 1.5. Oop. 1.5 from the right side there. Now let's go to the next place, which was at 2.5. From the left side, it approaches a height of not 2, not 3, but 3.5. And from the other side, it comes in at a height of 2. It approaches a height of 2. At 3.5, both sides approach a height of 2.5. And over here at 5, both sides approach a height of 1.5. And 1C. Tell whether it's left-hand continuous, right-hand continuous, both continuities, or neither. Well, the first one goes off to infinity. It doesn't have continuity at all. The right hand at -1 there's a solid dot, so we say it is continuous. So we call this right-hand continuous. So it's continuity from the right. At 2.5, the solid dot is coming in from the left, not from the right, so it's got left-hand continuity. At 3.5, there isn't a solid dot from either side coming into it, so neither. And then at 5, it's a solid dot coming in from both sides, and they meet up, and so it's got both. And I scored this a half a point for each of those, making this problem worth 8. And then 2, it says use numerical methods. So you pull out your calculator, and I had some people say, I can't figure out how to type this in, so I will explain as I do it. So we have a numerator, so I'm going to go parenthesis. Then I'm going to do the square root of 5, close parenthesis, and take that to the x. Then I'm going to go subtract 25 and close parenthesis for the numerator. And then I'm going to push divide. And then I'm going to open the parenthesis for the denominator because I got to keep it together, and I'm going to write 16 minus x squared and close the denominator. Now, first of all, I should check and see if it's even doable. If I put 4 in here, the square root of 5 to the 4th, square root of 5 times square root of 5 is 5 times square root of 5 times square root of 5 is another 5. That's 25 minus 25, so the numerator goes to 0. 16 minus 4 squared, well, that's 16 minus 16, so that goes to 0. So this, it is not determined whether there's a limit or not, and so we call it a not determined, indeterminate. Now, if one of them goes to 0 and the other doesn't, then it's a determinable limit. It's not indeterminate if one of them's a number and one's a 0, or vice versa, or one of them's an infinity, one's not, or something like that. Okay, so now we have to get it. Since I got it in y1, I can go to my table, second graph, and I can delete all the numbers that are in my x, and I want to check around 4. So if I put 4.01, that's close to 4, and I get negative 2.55. If I get a little closer to 4, 4.0001, I get negative 2.515. Let's go from the other side a little bit here. So that'd be 3.99 is pretty close, and that's negative 2.508. Let's get closer. 3.9999, and that's negative 2.515, just like it was for 4.001. So I'm going to write down the limit as negative 2.515 and show what I got. 4.01, I got negative 2.522. 4.0001, I got negative 2.515. And from the other side, 3.99, we got negative 2.508, and 3.9999 got negative 2.515. Okay, now we do no calculator work. Non-numerical. Don't use your calculator. Some of you guys just decided, I'm going to depend on my calculator to do all of these, and so you got a lot of zeros on your scores. Okay, we got square root, so typically we would multiply by the conjugate. You have to multiply the numerator and the denominator by the same conjugate. So this conjugate would be the square root of t plus the square root of 2. Numerator and denominator, square root of t plus the square root of 2. So this becomes the limit. By the way, I should check and see if it's indeterminate. If I put 2 in, that would be square root of 2 minus square root of 2, which is 0. And if I put 2 down here, I get 4 minus 4. So the denominator goes to 0. So it is indeterminate. So now I can try to do some more work to see if I can determine it. Right now, we're not sure if we can determine it. As t approaches 2, we get the square root of 2 times square root of t times the square root of t, which is t. Square root of t times plus square root of 2 is plus square root of t square root of 2, or square root of 2t. Then we're going to get minus square root of 2 times the square root of t. And then we're going to get minus square root of 2 times square root of 2, which is minus 2. Well, we can see that these are going to cancel out. We're going to get a t minus 2, which suggests that we probably should factor the t squared minus 4 to t plus 2 and t minus 2, like it does factor. We would still have this square root of t plus the square root of 2. And now, since those are gone, we'd have a t minus 2, which would cancel the t minus 2. And this becomes the limit as x approaches 2 of t minus 2 is gone, so that leaves 1 in the numerator. One of you forgot to leave the 1. And in the denominator we have a t plus 2, which is okay because that wouldn't be 0 if I put in 2. The t minus 2 is canceled. And we also have the square root of t plus square root of 2. And now, since neither of these is 0 when I put in 2, I do exactly that. And I get 1 over 2 plus 2, 4. And square root of 2 plus square root of 2 is 2 square roots of 2. And I'm supposed to multiply those, so I get 1 over 8 times the square root of 2. And there's the answer. Now, a couple of you, instead of multiplying by the conjugate, just factored the denominator. So I'm going to do it that way. So this would be the limit as t approaches 2 of square root of t minus square root of 2. And if you factor that t squared minus 4, that factors to t plus 2 times t minus 2. And then if we take the limit of this as t approaches 2, we can't factor a square plus a square, but we can factor a square minus a square. We have to think of this t minus 2 as the square root of t squared minus the square root of 2 squared. And so that would factor to square root of t minus square root of 2 over t plus 2 would stay. The t minus 2 could be factored to square root of t plus the square root of 2 times the square root of t minus the square root of 2. And these would cancel, leaving 1 in the numerator. And then we're right back to where we were up here, which then goes to these. So that's a couple ways to do number 3. Number 4. Most people did pretty well on here. Some of you really struggle with this algebra. So we have the limit as h approaches 0 of this 3 times something squared. The square comes before the multiplication, so we still have 3. And square the stuff. And a plus h times a plus h is a squared plus ah plus another ah, so that makes 2 ah's, which some of you missed, and then an h squared. And then we have a minus 2 times this, which means we've got to take a minus 2a and a minus 2h, which some of you forgot to do. And then we have a minus that we have to distribute to this, so this becomes minus 3a squared and plus 2a. And this is all over h. So this becomes the limit. We haven't taken that limit yet as h approaches 0. The minus 2a and the plus 2a cancel, and we need to distribute this 3, so we're going to get 3 a squared plus 6ah plus 3h squared minus 2h minus 3a squared. And the 3a squared and the minus 3a cancel, 3a squared cancel, and we get the limit as h approaches 0 of 6ah plus 3h squared minus 2h over h. The numerator now has an h in each one of these, so I factor it out, and so I get the limit as h approaches 0 of h times. H times 6a makes 6ah, so it's 6a. H times 3h makes 3h squared, so that's plus 3h. And h times a negative 2 makes a negative 2h, so this would be minus 2 over the h. And now the h's cancel, and I get the limit as h approaches 0 of 6a plus 3h minus 2. And if h goes to 0, I put 0 in here, and I get, now I'm putting in the 0, so I'm taking the limit. So this goes to 0. I don't write the limit anymore. I get 6a minus 2. It's the work I want to see done correctly. This one, 5. So we got the limit as x approaches 2. So we might as well factor because we have it indeterminate here. The numerator goes to 0 if you check it. 8 plus 4 is 12, minus 12 is 0. 8 plus 4 minus 12 equals 0. And then the denominator, 2 minus 2 equals 0. So it's indeterminate. So now, we're going to factor the numerator. There's an x in all of them, so I'm going to take that out, and I'm going to have x squared plus x minus 6 over x minus 2. So, let's continue factoring. So we have x times x plus 3 and x minus 2 over x minus 2. And what makes this indeterminate is that goes to 0 and that goes to 0, but they cancel out, and so now I have the limit as x approaches 2 of x times x plus 3. Now when I put the 2 in, I'm taking the limit. So I can drop the limit and just say it's 2 times 2 plus 3, which is 2 times 5, or 10. The bottom, is it indeterminate? Can I put 1 in here? I get the cosine of pi over 1. Cosine of pi, this is negative 1. If I put 1 in here, I get the natural log of e to the 1, or natural log of e. Well, that's 1. So this is not indeterminate. I can put in 1 because it doesn't cause any problem. And when I do, I get minus 1 over 1, which is negative 1. Come on. Next page. Okay, 2 main ways I saw people do this one, and I saw a lot of people make a silly error. This is not 1 minus cosine theta times cosine theta. that would be cosine theta minus cosine theta squared, not 1 minus cosine theta squared. This 1 minus cosine theta squared factors just like 1 minus x squared. It factors to 1 minus cosine theta times 1 plus cosine theta over theta. Now, I should have checked and see if this is indeterminate to start with. If I put 0 in, cosine of 0 is 1, squared is still 1. 1 minus 1 goes to 0. And the denominator is going to 0, so it is indeterminate. We don't know what it's going to be. It's not determined that it doesn't have a limit, and it's not determined that we can just plug in the number and get a limit. It's indeterminate. So now, many of you said, well, I'll put both of these over theta. Well, when they're multiplied, you don't do that. If it's plus, you can put it under each one. But multiplied, you can only put it under one of them. It's like saying 1 plus 3 over 2, 1 times 3 over 2, which is 3 divided by 2, or 3 halves. And some of you are saying, well, that's like 1 half times 3 halves. Well, that would be 3/4, which is not the same thing. You can't put the 2 under both parts of this. So you can't put the theta under both parts of this. So this becomes the limit. So let's choose wisely here. We know that 1 minus cosine theta over theta, as theta goes to 0, is one of our special ones. So we're going to say, as theta goes to 0, of 1 minus cosine theta over theta times, the limit of the product is the product of the limit, so limit as theta approaches 0 of the other piece, 1 plus cosine theta. Now this part we know is 0 from what we've learned and put on our note card, times, and this we can put in 0 and we get 1 plus, and cosine of 0 is 1. So this becomes 0 times 2, which is 0. Now the other way that this was done commonly was to say the limit as theta approaches 0 of 1 minus cosine squared. Many of you remembered that that was sine squared theta. But then many of you who did this then said, okay, this is going to be sine theta over theta times sine theta over theta. Well, there's only one theta. There's not two thetas. So you can't split it up that way, but you can split it to the limit as theta approaches 0 of the sine of theta over theta, which is a special rule, times the limit as theta approaches 0 of just the other sine theta. No other one. This, according to the rule, is 1. This is not indeterminate. We can put in 0. Sine of 0 is 0. 1 times 0 is 0. So the algebra is what really killed people on this one, or the factoring, or the idea that you can't put the theta under two things that are multiplied. Okay. Those of you who understood this did really well on it. A few of you had trouble explaining. The absolute value of x minus 2 is let's say it this way. The x minus 2 for x approaching 2 from the negative side, so when x is less than 2, that's approaching 2 from the negative side, is negative. Think about that. If I put in 1 or 0, minus 1 or 2 or 3, this will be a negative. So the absolute value of x minus 2 for x less than 2 is can be replaced by, well, the absolute value would change the sign, so we just say that, the change the sign of x minus 2. So this limit becomes the limit as x approaches 2 from the negative side of the negative of x minus 2 over x minus 2. Which then, these two cancel and it becomes the limit as x approaches 2 from the negative side of negative 1. And that limit is negative 1. Okay, this one. Some of you still try to say I can take the cube root of this part and this part separately. You cannot split the cube root up over two things that are added or subtracted. So you need to say that the limit as x approaches infinity, positive infinity, of the 3x plus 7x squared over the cube root of 5x to the 4th minus 8x to the 6th, as x approaches infinity, the lesser powered terms become insignificant. So this changes to, can be simplified to, as x is approaching positive infinity, to 7x squared over the cube root of minus, and some of you forgot to carry that, 8x to the 6th. And now, since we don't have this addition in here, we can take the cube root of the pieces, and this becomes the limit as x approaches positive infinity of 7x squared over cube root of negative 8 is negative 2. Cube root of x to the 6th is x squared. The x squareds cancel, and so we get the limit as x approaches positive infinity of 7 over negative 2, which is negative 7 halves. Now the other way to do this one is to say that the highest power in the denominator would be the cube root of x to the 6th, which is x squared. So divide the numerator, every term of the numerator, and every term of the denominator by x squared. But you got to do it correctly. So we'd have 3x divided by x squared plus 7x squared divided by x squared over, this is the cube root, and we're dividing by x squared on the outside. Well, the cube root of what is x squared on the outside? Well, that'd be the x to the 6th. So we're going to have 5x to the 4th over x to the 6th. Cube root of x to the 6th is x squared. That's where we get the x squared inside, minus 8. X to the 6th over x to the 6th. Now, this as x gets very large, this, which has a larger denominator than a numerator, will go to 0. So I'm actually taking the limit now. Plus, these cancel, and that's just 7 over, this has a larger denominator than the numerator, so I have the cube root of 0 minus, and these cancel, so I have just minus 8. And then this becomes 7 over the cube root of negative 8, which is negative 2. That's number 9, done 2 different ways. And now we'll do number 10. Put some backing here. Okay. This one's a little bit complicated, but not bad. We have sine squared of something. So that's like sine of pi x times sine of pi x. And in the denominator we have an x. And remember, the sine of some angle over the angle always goes to 1 if the angles are the same here. So I'm just going to put, now there's 2 x's here. That's why I can put an x under both of those. So those are going to do similar things. There's a 2, excuse me, but there's no 2 on these angles. So I'm just going to put the 2 over here with the last piece, which is 1 over 2 cosine 4x. Now I'm going to split each one of these up. So I'm going to have the limit as x approaches 0 of sine of pi x over x times the limit as x approaches 0 of sine pi x over x times the limit as x approaches 0 of 1 over 2 cosine 4x. Now, I should have checked earlier here. As x goes to 0, pi times 0 is 0. Sine of 0 is 0. Squared is 0, so the numerator goes to 0. And cosine of 4 times 0, cosine of 0, is 1, but 0 times that times 2 is 0, so this is indeterminate. Okay, so now, this first one, the limit, and the second one are the same, but it needs to be the same angle here in the denominator and out here. So I'm going to let theta be pi x. Therefore, as x approaches 0, comma, pi x will also approach 0. So I can make some substitutions. I can rewrite this as the limit as pi x, or theta, goes to 0 of sine of pi x, or theta, over, and x would be, if I solve this for x, be theta over pi, which means that pi would end up in the numerator or could be taken out. So I'll have pi, limit as theta goes to 0 of sine of theta over theta. That's what I want. This other one will do the same thing, so I'm going to have times the same thing, pi limit as theta approaches 0 of sine theta over theta. And this last part is not indeterminate. The numerator is 1. The denominator will not be 0 because cosine of 0 is not 0. It's 1. So we got times the limit as x approaches 0 of 1 over 2 times the cosine of 4x. So this is pi times 1, which is pi, times this is pi times 1, which is pi, and this is 1 over 2 times 1, which is pi squared over 2. So to determine the average velocity, we find the velocity, the distance at 3. So we'll find h of 3, and if you put that into your calculator correctly, so I'm going to do this because some people had trouble putting this in there. Clear the equation, and I'm going to type in negative 4.9x squared plus 15x plus 20. And I'm going to go, let's do it this way. Okay, I'll do it this regular way. Second table. And I'm going to delete the numbers I got in there. And I got to put in 3. And I get 20.9. That's the distance. Meters. Height in meters. And the time was 3 seconds. Then I'll put the height at 2 seconds. And that is 30.4. Okay, and it says y2 minus y1, 30.4. Oh, wait a minute, this is y2 because that's a 3. So I got to do 20.9 minus 30.4 over 3 minus 2. I could write it the other way, 30.4 minus 20.9, but then it would be over 2 minus 3. Anyway, the average velocity is not positive, it is negative. So 20.9 minus 30.4, is negative 9.5. Over 3 minus 2 is 1 meters per second. This is the change in the distance over the change in the time. So negative 9.5 meters per second is the average velocity over that interval from 2 seconds to 3 seconds. It's actually coming back down. That's part A. Part B, many of you found the height at 2 by just putting in numbers closer and closer to 2 in the height equation. We're not doing the height, we're doing the velocity, which means you have to do the height at some place close to 2, I'll just say at t, minus the height at 2 over the time close to 2 minus the time of 2. So we need to write that equation in here now. So in y2, the easy way to do this is to say y1 vars, y variables, y1 at, make that be the x, parenthesis x close parenthesis. Oh, and this is in a numerator of a fraction, so I have to put this in parentheses. So I got to back up here and insert a parenthesis at the beginning. Parenthesis, y1, or height of at x, minus the height at 2, which we know was 30.4, where I can type in 30.4, or I can type in vars y variable, that function, 1 at 2, close parenthesis. That's y2 minus y1 divided by parenthesis x2, which is the time at the later, which was x we decided to use, minus the x at 2. So it's got to be x minus 2. Now we want to check this out close to 2. So we're going to make x be around 2. Second table, and I'm going to delete what I have here and put in times near 2. Well, if I do 2.1, this is the distance, which some of you did, but I need the slope, and it's negative 5.09. When I put in 2.1, I get negative 5.09. If I do closer, 2.01, I get a height of 30.354, but I get a slope of negative 4.649 for 2.01. That's closer to 2. Let's get even closer. 2.0001. 2.0001. The distance is 30.4, it says, but the slope is negative 4.6. So the slope at that point is the speed, meters per second. Now let's come in from the other side and check and see if that's true. 1.999, that's close to it. Gives me 1.999 gives me a slope of minus 4.5995. Let's get closer. 1.99999. 5 of them. That one comes out to be negative 4.6 meters per second. So we got it getting close on either side, so the slope is negative 4.6 meters per second. So the speed at 2 was negative 4.6.